Picture this, the human brain, a marvel of complexity with around 120 billion neurons, each sparking with electrical impulses, creating a symphony of thoughts and actions. What if we could observe this symphony up close, with an almost microscopic level of detail? Enter the world of brain implants. These devices are leagues ahead of any external device like an EEG or MRI in their ability to monitor the brain's activity. Paired with advanced algorithms, they form the foundation for brain-computer interfaces, or BCIs, which can transform thoughts into digital actions, like typing on a computer screen or controlling a robotic limb. Today, these BCIs are primarily used in small-scale studies to address severe health issues, such as epilepsy or paralysis. But envision a future where anyone can interface their brain with technology, a world where the human mind can directly connect with robotics and other devices. To reach this future, we need better, safer brain implants. Today, these BCIs are primarily used in small-scale studies to address severe health issues, such as epilepsy or paralysis. But envision a future where anyone can interface their brain with technology, a world where the human mind can directly connect with robotics and other devices. To reach this future, we need better, safer brain implants. The most commonly used brain implant today is the Utah array. It resembles a bed of tiny nails with 100 electrodes protruding from a hard silicon base. To implant it, a portion of the patient's skull is removed, and the electrodes are inserted into their brain tissue. This procedure is highly invasive. Piercing the brain with electrodes can cause inflammation and scarring, which reduces the implant's effectiveness over time. To replace an implant, another invasive surgery is needed, piercing a different part of the brain. The risks of surgery and the potential for brain scarring dissuade many from using BCIs, even if they promise life-altering benefits. Take, for instance, the Layer 7 Cortical Interface, developed by Precision Neuroscience, a startup co-founded by Benjamin Rappaport, an original member of Elon Musk's BCI team. The implantation process is less invasive. A small incision less than a millimeter wide is made, and the implant is slid into the space between the brain and skull, conforming to the brain tissue without piercing it. Ideally, removal of the implant requires an incision of the same size. On June 6th, Precision announced that it had begun an in-human study of its brain implant. The system was tested on 3 patients at West Virginia University's Rockefeller Neuroscience Institute. Each patient had the implant temporarily placed on their brain during an open skull surgery for tumor removal. The brief 15-minute tests allowed the implants to read, record, and map the brain's electrical activity with unprecedented resolution. Peter Conrad, the study's principal investigator, remarked, "It's as if I was seeing the patient's brain think. A truly remarkable step towards understanding our own cognition." Precision has yet to test its implantation procedure in humans. However, initial tests on miniature pigs showed promising results. When the implants were removed after a month, there was no sign of brain damage. One of the potential challenges is that Precision's electrodes, unlike those in a Utah array, don't pierce the brain tissue, which could lead to movement of the implant. However, Rappaport suggests that their software should be able to account for any minor shifts. Looking forward, Precision plans to test its brain implant in 2 more people during this phase of the study. They also plan to commence related studies at Mount Sinai Health System, Penn Medicine, and Massachusetts General Hospital. In the coming months, they expect to complete an application to the FDA for permission to implant the device for up to 30 days, allowing it to be used for brain mapping procedures that help doctors diagnose various medical conditions. Precision's ultimate goal is to use their brain implants to help people with neurological disorders. I think that the brain is, in a lot of ways, the next frontier for modern medicine, says Michael Mager, Precision's co-founder and CEO. The fact that there are so many people who have neurological impairments of one sort or another, and that we have such crude tools to offer them, is going to change. It is changing. So, we stand on the cusp of a new era, a future where brain implants could transform our understanding of the human mind and revolutionize the field of neuroscience. The journey is challenging, but the potential rewards are truly incredible. If you like this video, subscribe below and hit the bell icon for notifications. Also, consider sharing the video with your friends.